Alrighty, in this video we're going to be looking at completing the square. One of the main reasons you'll want to complete the square is to turn a quadratic equation which is in its standard form, such as this one here. We're going to turn it into its turning point form, which easily allows us to identify the turning point, the axis of symmetry, and those sorts of features of the quadratic, which helps us sketch it. Of course, the general form of a quadratic equation also has its benefits for sketching, such as we can immediately see that the y-intercept of this quadratic is 12. However, turning point form is going to be an easier way for us to determine things like the axis of symmetry, where that function turns, and so on, so the maximum or minima. So, if we quickly look at this before we deal with this question over here, the turning point form of a quadratic equation may look more complicated, but there are some key features that we want to make note of. This value here, this 3, if it comes after a subtraction, it means that the x-coordinate, so the x-coord of the turning point is this value, so 3, which means on my quadratic equation, if I sketched it over here at 3, so 0, 1, 2, 3, that's the x-coordinate of the turning point, and this number at the end here is the y-coordinate of the turning point. So immediately, just like we can read the y-intercept of the general form, we can read the turning point of the turning point form. So if I move over here to this question, we need a way or a method of turning this into this, and this is what this lesson's about. So when we're looking at completing the square, we're going to need a monic, essentially, because a perfect square is much easier to determine if you have a coefficient of x squared of 1. So before I do the completing the square process, I have to factor out a factor of 3. So if I factorize out 3, I'm going to get y equals 3 outside of x squared minus 2x plus 4. And I can see if I expanded that, 3x squared, 3 times minus 2 is minus 6x, 3 times 4 is 12. And now this monic quadratic in the brackets is what I'll be completing the square on, and only later will I manipulate it to get it into turning point form. So what I'm going to do now is I'm going to, and this is the process you do every time you have a monic quadratic you're converting in by completing the square. I'm going to look at this middle term, the linear term. I'm going to halve the coefficient of x. And I'm just going to annotate off to the side. I might do it in a different color, maybe pink. I'm going to annotate off to the side that minus 2 divided by 2 is going to be minus 1. And I'm also going to square that number. So minus 1 squared is 1. So those are the two values that I'm just going to keep track of. This is the b on 2 term. So b is the coefficient of the linear term. So b on 2 is minus 1. And then I'm also going to be doing b on 2 squared, which is going to be 1. And they're both important in this process. So next step, I'm also going to have y equals 3 outside of. The first two terms remain the same, so you can plug them straight back in, x squared minus 2x. Now what I'm going to do is I'm going to take my b on 2 all squared term, which is 1, and I'm going to add it. But you're going to notice, in fact, just to keep it nice and consistent here, I'm going to add it and I'm going to make it pink so we can all see that this 1 is this one. And I'm also going to have this 4 at the end. But notice the difference between here and here is I've just randomly put a 1 in. I'm not allowed to just change equations by adding a number. So if I'm going to be adding a 1, I'm also going to be subtracting the 1. And by doing that, so this is the line here. By doing that, 1 minus 1 is nothing, and so this equation is exactly the same as this equation. I've not touched the value of the equation, I've just changed how it looks. And this is important, because by doing this, these first 3 terms that I've created, the initial first 2, and then this number halved, and then squared, if I add that on, this is my perfect square. I've completed the square, which is the point of this process. So, in my next line of working, y equals 3 outside of. Now, this is why I needed this first number as well, not just this one. The half of b, so minus 2 halved, which was minus 1, that's the number that goes in my perfect square. So I'm going to change my bracket because I'm going to have two sets here. Square bracket, and then in my perfect square I'm going to have x minus 1 all squared will give me this expression here. If I expanded this perfect square, I'll get x squared minus 2x plus 1. If you're not sure about that, feel free to go and do it yourself. Just this bit, if you want to expand this, please do, and you'll find that it equals this, which is the whole point. But I've also got 4 minus 1 at the end. So 4 minus 1 is just 3. So I'm going to add 3 there. And I'm nearly done. I've nearly turned this quadratic equation into this. The only difference being this guy doesn't have a second set of brackets like I do. So I'm just going to expand now, and I'm going to have y equals 3 times this term, because this is just a binomial expansion, 3 times this term, which is x minus 1 all squared, and then also 3 times 3, which is 9. And now you can see that these two things are identical. I've got this in turning point form, so straight away the question, which was determine the turning point of this equation, and get my green pen to make my final answer, I can just read straight off. If there's a negative in here, it means the number after it is the x coordinate. So I'm going to say turning point at 1. So the number after the minus is the 1. If that's a plus, it's just going to be negative. So if that was x plus 1, my coordinate for the x value would be negative 1. So it's just the reverse. And this number at the end is my y coordinate of 9. And so I have a turning point at 1, 9. And that helps me, if I can do that arithmetic, I can figure out where that graph turns. So if I just do a random sketch, I'll do it down here. Hopefully it's see through my body. If I had a sketch like this, at 1, 9, so if I have a 1 here and then 9 up the top here on my xy coordinates, then this point here would be my turning point. My a value tells me whether this is positive or negative. It's positive, so I'm going to have a quadratic that goes through 12. So if I extend this up, which would have been good from the beginning, this is going to be in my face. I'm going to step to the side. This is my y coordinate. 9, 10, 11, 12 is about there. So I'm going to have an y-intercept there, and I can sketch a parabola which turns there, and off it goes in both directions. If that was negative, it would be upside down and a very similar thing, but it's positive. There should also be no x-intercepts of this function. So if I did the quadratic formula on this guy, I should find that I get a discriminant, which is the bit under the square root of less than 0, which means there are no real roots, and we have to descend into our complex numbers for those of you who are doing specialist mathematics. If you're just doing methods, don't worry about anything I just said then. The main focus is this process and being able to do that. The first step being factorize out so you have a monic quadratic equation. That's this guy in here. Halve that term. Wait for the bell. Halve that term in the middle, which is this, and once you've halved it, keep that term in mind. This is why I wrote it, because the half of this b value is what's going to be in your perfect square. But in order to figure out what goes on the end, you need to square it and then add and take it away from both sides to keep the equation balanced. Then the bit, when you add it to the first two terms, is going to be your perfect square. This bit at the end is just an extra constant. And if you have a term outside of your brackets, because you had to factorize early on, make sure you just multiply that last term by that constant out the front as well in order to determine the y value for the turning point. So hopefully this video helped. If you need to go back, rewind, rewatch, slow it down, and if you still have questions, feel free to post them under the chat or just send me an email if you're one of my students. Hope that helped.